The general objective is to optimize government aid for the victims of a natural disaster with the use of a spatial analyst. There are two specific objectives. The first one is to develop a tool to perform a spatial analysis to validate the information from the records of victims. The second one is to differentiate between victims affected and people who doesn't qualify for the government aid. I have four research questions. Which are the most common mistakes to identify addresses of the properties? Is the information from the only record of victims adequate? Which are the most common causes of duplicate or cancelled records? How accurate is the information recorded in the only record of victims? Before I start, I will explain two acronyms. The first one is RUD, Only Record of Victims, which is a database that stores information of victims of natural disasters in the country, and the second one is UNGDR, National Unit for Disaster Risk, which is the government agency for disaster response. The problem is subdivided in three problems: fragmentation of information systems, number of affected people is greater than the total population, and wrong validation of information. Here you can see an example of the first problem, where the only record of victims has a greater number of affected people, dead, missing persons, and injured, than the National Unit for Disaster Management, and it's because they don't share information. For my project, I will use the only record of victims database because it's the official record that the government uses for financial aid. The second problem, number of affected people is greater than the total population. I found an article called The Impact of the 2010-2011 La Niña Phenomenon in Colombia. In the research, they made a map of affected people normalized by the total population, and they found that 37 municipalities had anomalous normalized values higher than 1. The most extreme cases were observed in some municipalities from the Pacific and Caribbean states, where the number of affected individuals was nearly twice the total population. They believe this was a consequence of inaccurate population projection from the 2005 census or incorrect registration from individuals affected by flooding, with many individuals registered multiple times. The last problem is the validation of the information. The picture you see is one of the three pilot exercises in the Atlantic, Valle, and Antioquia municipalities. They found that 30% of the registered homes to be rebuilt not require or did not exist. But at the end, everyone got a new house, and if you see in the picture, there are some properties that are completely fluid and ones that are not. The methodology followed is the application of three steps to meet the general objective based on case studies and academic papers. The first step to solve the problem is to properly identify the properties affected by the disaster. For this, I will use the addresses of affected records to locate the property by geocoding or topographic concepts as triangulation. The second step is the validation of property. It involves using satellite and aerial photographs to verify that indeed the site was affected. Using a case of study of Japanese World Bank Risk and Damage Information Management and a software called Socket, the differences in the images will be identified, and this corresponds to the damages suffered by the properties. The final step is the comparison of databases. Refers to the proper management of the data to be exchanged between different databases and to corroborate more information from the records of victims, as well as create new databases for future times.